Okay, this is my presentation on the Jupyter Notebook, linear regression model, and the Monte Carlo simulation model that we talked about in the last class. I just want to go over the overview and actually just fix this a little bit. This is my lab 4. I'm going to select the data set of my choice and utilize the coding scripts that we were shown in class. In Jupyter Notebook, and I'm going to create the linear regression model with my own data set and the Monte Carlo simulation model with my own numbers inserted. And in the end, I saved it as a HTML and also in PowerPoint. And so this is what was provided to us. I'm just going to move on. All right, so I got my data from World Data. I used Capital Bike Share from 2011, 2012. I chose this data because I feel that it was good for what the lab I needed. It has some numerical values that will help me to compare and create the regression model, linear regression model. So first of all, I launched Jupyter Notebook from Anaconda, and we used Jupyter Notebook in first semester, so I was familiar with it. I opened up the examples in a separate tab that I was working on with my own data. So I had the example script here, and I had my own tab here, so I could go back and forth and compare what I was doing. So again, I did run into some errors, and for example, this was one of the errors that I ran into. Whenever I tried to load in the course right away, I ran into an error, but quickly I realized that I was just missing some quotes around the location of my data. I left my errors in my HTML this time. Last time I tried to clean it up as much as I could, especially for my last final presentation, I really cleaned it up. But I wanted to show the work as I went through it. So the errors are within my HTML. But like I said, it was much easier to go through the errors this semester. So this is the data that I brought into Jupyter Notebook. And as you can see here, I started doing the same things that was in the script that was provided, which is right here. This is what was provided, and then beside it, I worked on my own script. Just going back. So as I was doing it, though, I noticed that even though I pulled my data out of this, and I just had this table as my BDF as my working table, without the data that I didn't need from the original import. What I noticed is that the titles, because they had spaces, I kept getting error messages whenever I was creating the initial plot table. So I renamed the titles to not have spaces. I'm sure I could have researched this a little bit differently and went the opposite way and tried to figure out how to actually keep the spaces in there. I did try a few times with different quotes, and it did not work, so I just renamed to be temperature and users, which are the two columns that I would be using in my plotting. So these are my charts, my plotting charts. There was a lot of data, as you can see, so it almost looks like it's all mashed in together, but it does work. So this is me creating the first one, the first plotting table here in green, and then this is actually going through and creating the linear regression line within it, which is on a pretty good slope, I find. It's a little bit higher up, but it is in a good slope area. And then this is, I followed through the lab, and I plotted the train data, the test data, and the actual data as the example did. So these are my three. This is the first one is my test data. Second, which is I think 20%, and the second one is my train data, and the third plot is my actual data. So, and then I finalized this project with the predicted data chart. And once again, I followed through with the provided scripting for the lab. And this is my predicted data chart. So as you can see here, this is, it was kind of odd. The actual temperatures were much higher for the prediction than what they were at. They definitely went up a lot, which I kind of thought was very odd. Like 36 to 50 is different for temperature, but if you actually look at it in numbers, it kind of like it is very high. So, oh yeah, just to go over, I'm just gonna pull up my actual lab. This is it. So here, oh, this is the other lab. One second, I'm just gonna pull up the linear regression lab. And this is my linear regression lab. So as you can see, I went through and I imported everything that I needed to import. I read the data correctly here. And then I went through. This is where I was talking about right here, where I couldn't get the space to work. So then here I renamed the columns to not have spaces, and then I worked through my temperatures and I plotted all of everything that was in the table, which was, like I said, it was a lot of data. So all these little dots are overlapping each other. And it was for 2 years of renting those bikes in a warm place, so you can imagine. And then as you can see here, I just went through these. I was running into some more errors here, but most of all, like in between all these errors, I actually did the script, put the script in, and I actually came out with what I was supposed to come out with in the end, um, for everything. And I'll upload this HTML file. Just going to head back to PowerPoint. So next, I did the Monte Carlo. I kind of changed the data. So I said it was a weekly delivery service of fruits and vegetables. The weekly fee is $15. Customers can cancel at any time. Approximately 2,000 customers. The weekly recurring revenue, the MMR, is $30,000, and the annual cost of maintaining service is fixed at $1 million. For simplicity, there's no seasonal customers expected for the next year, so 52 weeks, and it'll be similar to the last 260 weeks, which is 5 years. To set aside cash, ensure an 85% accuracy for 1 million, for 1 million for the year. Actually, sorry, I think this was 99%. I didn't actually change that. So what I did is I used a notepad to modify the example. And I brought it into Notepad and I went through and changed everything. So you can see here I did it 52 weeks, 200, and I changed the correct numbers, so 260 weeks, which is a 5-year span. I set it to 2,000, and again 260, 52 weeks in a year. And I just kind of went through Notepad and changed all my numbers before actually putting it into to the actual Jupyter Notebook. And then once I did, this is the Monte Carlo simulation that I came up with. So the kurtosis looks to be leptokurric, and it seems to be a positive kurtosis. I could see here that it also has a very long tail on the right side. Oops, I didn't mean to do that. On the right side. And then I uploaded the HTML files to a web hosting site, and these are the links for both of the HTML files that I went through. So I'd just like to conclude. This is on this lab. The data set wasn't as hard to find as I thought it would be, hence I'm getting the lab done a little bit quicker. And I'm just going to go over one more thing. This is the Monte Carlo, and this is where I ran through it. So like I said, here's the information that I copied from Notepad after I changed all my numerical values. And this is the actual chart, the Monte Carlo simulation chart that I came up with for the 1 million. And that's it. Thank you. Oh, actually, sorry, 1 second. Here we go. That's it. Thank you.